In this lesson, we're going to learn how to determine the angle that is created by a point plotted on the coordinate grid. So in this question, we can see that we're told the point 6, negative root 13, lies on the terminal arm of an angle in standard position. First, we're asked to write the 6 trigonometric ratios for the angle, and then we're asked to solve for the angle measure theta, where theta is in between 0 and 360 degrees. That is, it's a positive angle. Okay, well, let's go ahead and get started. And I guess the first thing we're going to do is we're going to sketch, get an idea of where this point is. So if we have the coordinate grid here, and if we recall, let's just put some quadrant numbers on here. So this is quadrant 1, we have quadrant 2, and 3, and quadrant 4. Okay, so this point here has 6 for the x values, so it's positive 6, 2, 3, 4, 5, 6, so maybe over around there, and that's on the x-axis, and it has negative 13 in the y direction, which is down around there, and that's on the y-axis. So the point is going to end up being right about, I'm going to guess right about there. Okay, so the terminal arm will be going through that point, and what we're asked to solve is first the trig ratios of the angle and solve for the angle measure theta. So whenever we're given an angle in standard position, the first thing we do is we drop a horizontal line, or rather a vertical line, to the x-axis, and that gives us our related acute angle theta, which will lie right in there. Okay, well, let me just draw this triangle sort of blown up here so we can see it in a little more detail. We have a right angle triangle. We have a right angle in the corner there. Our related acute angle right here is theta. And the angle measure, or the measurements we had 6 on the x-axis. We had a negative root 13, and that was the distance down here on the y-axis. And this hypotenuse length is the radius, right? So that is the radius of this circle. And in order to write the trig ratios for this angle, we're going to need to solve for this r value here, the radius. Well, to do that, we're just going to use the Pythagorean theorem. We know that in a right angle triangle, a squared plus b squared equals c squared. So in this case, a we can use as the 6, so 6 squared. And then to that, we will add, and it's negative root 13 squared, and that is going to equal c squared, and c is our radius. So 6 squared is 36, plus root 13 times root 13 is just 13, and a negative times a negative is a positive, so this is just going to turn out to be positive 13, and that is going to be c squared. 49 is c squared, meaning our radius c is 7. So I can put that value in right there. The radius is 7. I'm pleased to see a value of 7 because the hypotenuse should be the longest side, and sure enough, 7 is greater than 6, and it's also greater than root 13. Okay, so there's our right angle triangle, and we were asked to write the 6 trigonometric ratios for this angle. So let's start, and we'll write the 6 ratios. I guess we can just say that sine theta equals, well, sine is opposite, and this is the opposite side, over the hypotenuse, which is our radius. So negative root 13 over 7. The cosine of theta is, cosine is adjacent. There's the adjacent side to this angle over hypotenuse, so it is 6/7, and notice that that is positive. The tangent of theta is the opposite side, so negative root 13 over the opposite side over the adjacent, which is 6. And there's the tangent ratio. Now, if we just, right now at this moment, just do a quick little cast check. Well, remember the cast ratio, right? C, A, S, and T. In quadrant 4, the only trig ratio that should be positive is cosine. And when we look at the cast rate, or the values here, we can see that sure enough, cos is positive 6/7. The other two are negative, so I'm okay with the cast rule check. Those ratios are good. Well, let's write the reciprocal trig ratios now. So the reciprocal of sine is cosecant, and that is going to be equal 7 on top, root 13 on the bottom, still negative. Secant is the reciprocal of cosine, so secant theta equals the flip, 7/6. And tangent, well, it has cotangent as its reciprocal, and it will be 6/root 13, and again, that is also negative. Okay, so part 1 of the question is done. Write the 6 trig ratios for this angle. There are the 6 trig ratios, and they're exact values. We don't need to evaluate them as decimals. Leave the radical signs alone. Those are exact. Okay, the next part of the question was solve for the angle measure. All right, so let's solve for this measure theta. And to solve for theta, I could use any one of these trig values. So let's use the cosine value. That looks, nice and easy, 6/7. Don't have to worry about the radical signs. So if I had that cosine theta was equal to 6/7, that means that theta is the inverse cosine of 6/7. Now when I enter that value into the calculator, so second cosine of 6 divided by 7, we can see that the answer it provides is 31.0027, which is rounded to the nearest degree. We're just going to round to 31 degrees. So therefore, theta is 31 degrees. Okay, but we need to be careful here, right? If I was to graph the angle 31 or plot that in standard position, well, 31 degrees would be up here, right there, 31 degrees, and that would be in quadrant 1. But clearly, this point does not lie in quadrant 1. It lies in quadrant 4. So we need to come up with the measure of the angle in quadrant 4. That is, this measure here, starting there, going all the way around to the terminal arm. And that means that because these related acute angles have the same ratios, that is, this 31 in this direction would match 31 in this direction here. Okay, so this angle here is 31 degrees, and it is in this direction, negative. So how do we find the actual measure of theta? Well, pretty easy. All we're going to do is we're going to say our theta in quadrant 4 is equal to 360 degrees minus 31 degrees. And when I do that, I get 329 degrees for our measure of theta. So that is the angle measure, and it is between 0 and 360, so it's a positive angle, and that is the angle measure of that point, which is in quadrant 4. Okay?